Dear students, we are going to solve one problem in engineering mechanics statics where the problem is like this. We have two rollers identical in size and their weights are same, and they are supported by one vertical wall and one inclined floor or inclined plane. These are the points of contact A, B, C with the floor or the inclined plane and the wall. We have to determine the reactions at these supports A, B and C. That is the problem. Now, I will show you solving this problem in three different methods. Three different methods mean basically considering different free body diagrams basically. So, in method 1 I will show first. So this I start with method 1 where I will consider that two rollers together as the system. So you can see that I have written free body diagram of two rollers as a whole. Now one thing that we have to keep in mind that while drawing free body diagram, the necessary condition is that while we are applying the condition of statics or dynamics, if both the rollers are static, then definitely we can either decouple them, that means individually we can analyze this or this, and we can solve the or we can apply the condition of statics for this system for individual rollers, or we can combine this and we can write the equilibrium equation for the system as a whole. So as long as they are both not moving, we can apply either on this or as a whole. Okay. Now that means the condition of statics will be applicable for either this or the system as a whole. That you have to understand. The first method that I will show you is with this. That means considering the two rollers as a whole. That means these two as a whole. That is the system. Now, what is the benefit of this? Benefit is that you can see that means I will choose which one to select my system depends on the problem at hand. That means I need to solve reaction at A, reaction at B and reaction at C. That is why I am taking these two together, because you see that there is a contact at D, that is in between these two rollers. In the problem, the contact reaction at D is not required to be solved. So that is why I have taken two as a whole for solving this problem. Okay. Next, how many equations we need for solving this? There are three unknowns. Therefore, we need three equations. What are they? Two force equations we can write. That is summation of fx is equal to 0, summation of fy is equal to 0 for this system, and the sum of moments about any point equal to 0 for this system. Because this is static, so moment will be 0 about any point, any arbitrary point. Now for this we have to first specify the coordinate system. So in this case I have selected the coordinate system in such a way that while writing the equations, the variable per equation will be minimum, so that we can easily solve some of the equations. So I have taken x in this direction, y in this direction, because you see that RA and RB are aligned with y direction. So when I write the fx is equal to 0 equation, in that case RA and RB will not appear, only RC will appear along with Q. So in that case RC can be easily solved. So that is the strategy. That is how the x and y direction can be defined. You can define horizontally and vertically also. In that case the equation that will be solved will become little difficult. So I have taken that fx is equal to 0, fy is equal to 0 and mz is equal to 0. Next, while I have written summation fx is equal to 0, you can see What is that? Along this direction, that is this direction, the force summation is 0. So what is that direction? Along the inclined plane. Now therefore, along the inclined plane, what is the component of RC? These two will vanish. These two since they are perpendicular to this direction, therefore these two forces will not appear. RC will appear. RC, what is the angle of RC? You see that this is the inclined plane direction. Therefore, this angle is theta, right? As this is theta, therefore this is theta. This is the direction of the plane and this is horizontal. RC is horizontal. So this is the angle theta. That is 30 degree here. Now therefore, the component of RC along this direction is RC cos theta. Along this direction. Okay. So I have written along positive x direction, it is RC cos theta minus q sin theta. Why? Because q is in this direction. So with y direction, the angle of q is theta. This is theta. Therefore, perpendicular to that direction, the component of q is q sin theta. Similarly, q sin theta for this, therefore q sin theta plus q sin theta, it will be q sin theta and q sin theta. So RC cos theta in this positive x direction and q sin theta and q sin theta in the negative x direction. So RC cos theta minus 2q sin theta. Therefore RC is equal to 2q sin theta by cos theta, that is equal to 2q tan theta. Now we have just put the value and we can solve. So that is in Newton, you can solve it. Okay. So that can be calculated and that can be solved. That is coming to be basically 1132.76 newtons. You can just put the values and can calculate. Next, RA plus RB. What is that? Summation Fy is equal to 0 in this direction. Summation Fy is equal to 0 in this direction. So RA plus RB, you see both are in the positive x direction, minus this one q 2q cos theta. So q is in this direction, so along the negative y direction, q cos theta. So that is why minus 2q cos theta. So one q cos theta for this, another q cos theta for this. So minus 2q cos theta here and RC sin theta, because RC is inclined with the y direction, therefore this is in the negative y direction, this part, and that is RC sin theta. RC sin theta. So therefore RA plus RB in the positive x y direction, 2q cos theta in the negative y direction, and RC sin theta also in the negative y direction is equal to 0. Therefore RA plus RB is equal to 2q cos theta minus plus RC sin theta. Now what is RC? RC is equal to 2q tan theta. So I have put it 2q tan theta sin theta. Sin theta is here. So that is equation 5. This is equation 4. Next, from the moment equation, if I consider the moment equation can be taken about any point, but remember moment equation can be taken about any point, but here we have to understand that the point we will choose is one which will basically eliminate most of the forces, so that the equation can be easily solved. So if I take moment about this point, this center, then you see that this force is passing through this center, this force is also passing through this center, and this is passing through this center. So therefore these three forces will not be there in the moment equation, only this and this force will be there. So this is unknown and this is known, therefore I can solve for this from the moment equation itself. Therefore we have written, considering moment about the center of the lower roller. This is the lower roller. So this is the lower roller. So center is taken as the moment center for the moment equation, and we have written this one. So this will eliminate these three one that I have just mentioned, that RC, RB and Q, these three will be eliminated, and we can simply write, you see, that this one, about this equation, it will be RA multiplied by 2R, because RA is perpendicular to this line. So RA multiplied by 2R, and Q cos theta in this direction multiplied by 2R. So RA into 2R in the counterclockwise direction, you can see counterclockwise RA into 2R, minus Q cos theta into 2R in the clockwise direction. So Q cos theta into 2R in the clockwise direction. What is that clockwise direction? This one is clockwise and this is counterclockwise or anti-clockwise. Therefore, clockwise, a counterclockwise moment is taken as positive, clockwise moment is taken as negative. Their sum is equal to 0. So sum means, because I have taken negative, that is why it is sum we have to consider. Therefore RA is equal to Q cos theta, because 2R will cancel, therefore RA is equal to Q cos theta here. Okay, so that is equation 6. Now we have already solved RC, we have already solved RA. Therefore from this equation, that is equation 5, if we put RA and RC, then we can solve for RB. Therefore we have put it here. RB can be determined to be this one. So RB is equal to 2Q cos theta plus 2Q tan theta sin theta minus RA. What is RA? RA is equal to Q cos theta. Therefore we can write Q cos theta minus RA. RA is again Q cos theta, so 1 Q cos theta will cancel, therefore it is Q cos theta plus 2Q tan theta sin theta. So RB is equal to this, RA is equal to this, and RC is equal to this. Now if we just put the values, we can determine the values. So Q is equal to basically how much? 100 kg multiplied by the gravitational acceleration, that is G 9.81, multiplied by cos theta, means basically root 3 by 2 newtons. So we can determine that to be RA to be 849.57 newtons. You can determine. Next, RB, just put the values of this and you can determine RB to be, for this particular set of values, that is 100 kg and 30 degree. So you can solve for RB. RB is equal to 1415.95 newtons. So that is method 1, where we have considered the two rollers as a whole. Okay, so that is the first method. Now we will go for the second method. In the second method, what we do, we are considering these two rollers as individual systems. So we have drawn the free body diagram of this roller. How many forces are there here? 1, 2 here, the contact reaction here at D, and another contact reaction RA, right? So 3 forces in equilibrium, therefore we can apply the Lami's theorem. So we have applied Lami's theorem. So we can write RA by Now let us first identify the angles. So you see that this is vertical, this is along this direction. What is that direction? This is theta. This angle is theta. This line is horizontal. This is theta, and this is perpendicular to this. That means this line and this line, they are perpendicular to each other. RD is where? RD is basically here. So you see that this line and this line, definitely they are perpendicular to each other, because this is inclined, this is an inclined plane, and these are the identical rollers. So this line must be parallel to this, therefore this line must be perpendicular to this. Therefore this force and this force, they are perpendicular to each other, therefore this angle is 90 degree. And q, this one, therefore q is vertical. Now since you see that this angle is how much? This angle is theta, because this is theta, so this will be also theta. Therefore this will be pi minus theta, or you can say 180 degree minus theta, this angle. And this is also theta, this angle. Therefore the whole this one angle will be 90 degree plus theta. This whole angle you can see up to this. I guess it is clear. So if I just mark with some color, then this angle with red marking, it is 90 degree plus theta, and the angle that I mark with blue, this is 180 degree minus theta, 180 degree minus theta, because this angle is theta and this angle is also theta. Okay, so identification of the angles are very important for applying the Lamis theorem. So first understand the geometry, determine the angles, then apply the Lamis theorem. Lamis theorem, in that case it is very simple, but identification of the angles are very important. Okay, so what we do is we write the Lamis theorem. Here you see that RD is the one angle which actually in the problem I need not solve, but for this application we have to solve RD, otherwise we cannot solve for this uh, for for the other free body diagram. Okay, so first do that. RA by sine of the opposite angle, so RA divided by sine of the opposite angle, that is 90 degree plus theta, is equal to Q by this, that is sine 90 degree, is equal to RD by this angle, sine of this angle. So that is RD by sine of 180 degree minus theta. I guess you understand. So I can write, since sine 90 is 1, therefore I can write RA is equal to Q sine 90 degree plus theta is equal to cos theta. So RA is equal to Q cos theta, and RD is equal to, again, sine 180 degree minus theta is equal to sine theta. So RD is equal to Q sine theta. So these two we have determined first from the free body diagram of the top roller. Top roller will include three forces, so that we will solve first. Next, once I know RA and RD, now we will draw the free body diagram of the lower roller. For the lower roller, how many forces will be there? One due to the weight, another the contact reaction here, another contact reaction here, and the fourth contact reaction will be, the fourth force will be a contact reaction from the another roller. So there will be four forces, 1 2 3 4. Now see this one, weight RC is horizontal, RD is inclined, and the inclination is same as the angle theta. That means what is the angle here? That is theta. This angle is theta, and this is perpendicular to the inclined plane, and therefore this angle will be 90 degree, as we have seen for the last problem and last free body diagram. Okay, So this is RB and this is RC and this is RD. Okay. Now you see that here we have four forces and we cannot directly apply Lami's theorem. So what we will do is we will use, how many unknowns are there first? RD is already solved. RB and RC, these are the only two unknowns here that we have to understand. Out of the four, Q is known because it is weight. Weight means 100 into 9.81. Next RD. RD means basically the contact direction from the other roller, that is already solved here, you see RD. And RB and RC, these are only two unknowns here. So two equations are required. So two equations we have just got. Okay. Fx is equal to 0, Fy is equal to 0. You may say that why not moment equation? Because since this is a kind of particle, there is no possibility of rotation of this. So we will only be we will only be able to use the force equations. Okay. Next, we just write the equations accordingly. Now you see that we have written the x and y directions because that is very important always while we write these equations. Defining the directions is very much essential, otherwise you cannot write this. That you have to understand, because x does not mean anything. There is no universal direction of x and y. So while you write this equation, before that defining the direction is very important. Without that, that equation will have no meaning. Okay, clear? That is to be remembered. Okay, next is we write the equations. So along the x direction, what are the forces? Now you see that again, why I write this, why I actually define the x and y direction along these directions, because in that case one of the forces will be eliminated in one equation, at least one equation. So you see that in the x equation, this RB will not be appearing. Okay, so, but RC will appear in both the equations because RC is inclined to both the directions. So, RC will appear in both the equations, but RB will not appear in the x direction. So, at least in one equation, you can directly solve for RC. That is the reason why I have selected this direction. So, while selecting the direction, you have to keep that in mind always, so that your calculation becomes convenient. Okay. So fx is equal to 0, will give that RC cos theta. Why? RC is making angle theta with the inclined plane, because this is horizontal, and this is inclined. So the angle between RC and the inclined plane is, that is theta. So RC, that angle is theta. Therefore you can write along the x direction component of, that means while writing the equation and means expanding the equations or writing all the components from all the forces, we will only see that what is the component of a particular force. Individually we will go to all the forces and see what component it will contribute in a particular direction. So RC, what is the component of RC in the x direction, that we will see. So component of RC in the x direction is RC cos theta, because this is theta, therefore in this direction it is RC cos theta simply. Then RD, RD, RD is along this direction and it is x direction, so simply minus RD I have written. No means decomposition, simply RD comes as a whole. Okay, RD is along this direction. Next, because this is the direction along the inclined plane, I have taken the direction x, so it will directly come RD. Next, q sin theta, what is that? Q is in this direction, this is angle theta, so component of q along the inclined direction is this one, that is q sin theta in the negative x direction, so minus q sin theta is coming. So 1, 2 and 3 forces will come, this will not come because this is perpendicular to x direction, that will not come, therefore simply it will come. And you see that RC is the only unknown, RD is already solved here, and you can get RC. So RC is equal to q sin theta plus RD by cos theta, and RD is equal to Q sin theta again. Therefore, it is 2Q sin theta by cos theta, that is 2Q tan theta, that we have done for the last problem also. You can see that RC has come to be 2Q tan theta in the first method, right? So similar things are coming. Next, so RC is 2Q tan theta. Therefore, next if we write this equation, that is the equation 4, that is summation of forces in the y direction to be 0, we can write that RB minus RC. So because RB is along the y direction, positive y direction, so RB will come directly, right? Here RB will come directly along the positive y direction. Now what is the component of RC along the y direction? It is this one, positive negative y direction. So what is that? This is theta, therefore this is RC sin theta. RC sin theta in this direction, in this negative direction. So this one, this one. So it is to be in this direction, right? So RC sin theta. Next, Q. What is the component of Q along the y direction? This one. So from this along this direction. So that is what Q, and this angle is theta, therefore Q cos theta. So Q cos theta but in the negative y direction. So RB in the positive y direction, RC sin theta in the negative y direction, and Q cos theta in the negative y direction. Therefore RB minus RC sin theta minus Q cos theta is equal to 0. So from that, since we have already determined RA and RC, here we can RA is not needed, we can solve because RC is already known, so RB can be determined. So what is that? Q cos theta plus RC sin theta. RC is again Q 2Q tan theta, so Q cos theta plus 2Q tan theta sin theta. So RB is equal to Q cos theta plus 2Q sin theta tan theta. That is already determined in the first equation, you can see. So Q cos theta plus 2Q tan theta sin theta, right? So same as earlier. So you see that we have solved the three equations, that means three unknowns in method 2 also. So in method 2 what we have done? In method 2 we have individually drawn the free body diagrams, considered the free body diagrams and solved for the equations. Here we have solved two equations. These are two equations. One equation is here, another equation is here. I told in the class that the number of equations are equal to the number of the equation sign, equal sign. So there are two equations and we have solved RA and RD here, and here also we have two equations and we have solved RC and RB. So in this case RD although is not asked to be solved, but it is required to be solved because RD is the connection between the roller 1 and the roller 2. So we need it. Therefore, in method 2 we have done the solution. Next, we will solve in the method 3. Okay, just we have calculated the values. You can calculate as it is seen in the screen. So you can just go for the solution. The values are like this. You can solve this. And another thing that you can observe is that RB is greater than RC is greater than RA. So that means where is the maximum reaction? Maximum reaction is at RB, minimum reaction is at here, and in between the reaction is here. So roller A is pressing roller B and that is pressing at this wall. So here the reaction is maximum, here the reaction is minimum, so and here the reaction is in between RA and RC. Okay. Now next we will solve with the method 3. In method 3 we have basically combined the method 1 and method 2. See what we have done. In method 3 we have first drawn the free body diagram of this roller so that we can determine RA, but in the second case we have drawn the free body diagram of these two as a whole. Therefore what it actually reduces, that for the first we have determined RA, and therefore in the second case, how many unknowns are required? How many unknowns are there to be solved? RB and RC. RA is already solved. So here, if we write two equations, we can solve the two unknowns without solving the moment equation. So in this case, we are actually getting rid of the moment equation, and we can solve directly the force equations and determine the unknowns. Okay. So here, therefore, just in this case, we will be able to apply the Lami's theorem as earlier. Since you have done already, I am not explaining it. You can solve RA. I have not solved for RD because RD is not required here. So simply solve RA, and you can, by identification of the angles, as earlier, you can solve RA. Next, what you do? That means here we have used the Lami's theorem. Next, what we do? We have written the force equations only, and again in this case what I have done is I have taken the direction of the coordinate as horizontal and vertical, because RA is already solved, so only unknown is RB, and therefore you can either take along the inclined direction or along the horizontal direction. That will not matter much. Therefore I have taken in this direction as horizontal x direction, and vertical y direction. That you should understand. Okay. And just wrote the moment force equations, that is summation fx is equal to 0, summation fy is equal to 0. Summation fx is equal to 0, you can see that is equal to rc. What is that? Rc in the positive x direction, and rb and ra both will have component in the x direction, that is in the negative direction. So it will be rb sin theta and ra sin theta, but q will have no component in the x direction because q is perpendicular, q is vertical. So rc is horizontal, q is vertical, therefore q will have no component in the x direction. So q is not appearing in this equation, you can see. Okay. So simply rc minus rb sin theta minus ra sin theta, and therefore rc is equal to ra plus rb into sin theta, right? So next, I guess it is clear to you. RC is coming purely, full component of RC is coming in the positive x direction, and component of RB is what? You see, component of RB, this angle is theta, this angle is theta, this is the vertical direction, this is the vertical direction, and therefore component of RB along the horizontal direction will be RB sin theta. Component of RA in the horizontal direction will be RA sin theta. So RC minus RB sin theta negative direction, RA sin theta negative direction. This is positive, this is negative, this is negative. Therefore RC minus RB sin theta minus RA sin theta is equal to 0. From that I can write that. And summation Fy is equal to 0. Next you see that RB cos theta along the positive direction, RA cos theta along the positive y direction, and Q, that is 2Q in the negative y direction. So RB cos theta plus RA cos theta minus 2Q is equal to 0. Therefore RB is equal to 2Q by cos theta minus RA, right? So here RA is already calculated. You can put the value of RA and you can calculate what is RB. And if you put RB in this equation, you can see RA is already known, RB is just calculated, therefore you can solve for RC. And RC is equal to RB is equal to 1415.95 and RC is equal to 1132.76 newtons. So these are the three methods that I have discussed. One is the first one, what I have done. First one we have considered. So these are the three methods that we have used. You can take any method, or you can consider any method, you can adopt any method for the solution, but understanding of the method is important before trying to solve the equations. Thank you.